Alright, so the trick to this one, it's tempting to clear the fractions by multiplying by a common denominator, like you do if there are constants underneath, but that leads to trouble with this guy. So they've rigged it so that if you write it like this, and then you make a substitution, if you simply let, let's say a equal 1 over x and b equal 1 over y, then these equations become 1a plus 3b equals 2 and 4a minus b equals negative 5. And you're like, oh, I can solve that. So I think I'm just going to do it with substitution maybe. So I'll say that a equals 2 minus 3b. So I'll do 4 times a. 2 minus 3b minus b is negative 5. So 8 minus 12b minus another b is negative 5. We keep solving. So looks like b is 1. And then you plug it back in to that first guy. So a will equal 2 minus 3 times 1. So a is negative 1, which is boring because when you go, because ultimately you want to know what x and y are. So if a is 1 over x and a is negative 1, then you have to solve this little system to get that x is negative 1. And if b is 1 over y and b is 1, you have to solve, not system, that little equation to get that y is 1. And if the equation were anything more interesting, you would have to do a little bit more cross multiplying, or you could just simply flip it over is eventually what happens. So had you gotten an x equals 2/3, then the a would have been 3 over 2, because it's just the reciprocal. Cool. That's fun. Alright, so they gave us that lovely 3 hours 36 minutes, which we're going to have to do something with that. 36 minutes is 36 minutes over 60 minutes in 1 hour, right? That's 36/60ths of an hour, which is reduces down to 3/5 of an hour, which thankfully is 0.6. So 0.6 hours. So we're going to, and so 3 hours and 36 minutes is going to be 3.6 hours for against the wind, and with the wind they said it was 3 hours. And we set up this like rate times time equals distance chart. So the distance both going there and back is 1800. Against the wind, you go your normal speed, your normal rate, but the wind is pushing against you, so minus w. And with the wind, you're going your normal rate plus w. And so you get these two equations with their two unknowns. So the first one is that the rate times the time equals the distance. And then the second, rate times time equals distance. And then instead of distributing, it's going to be nicer to divide both sides by 3.6 here and divide both sides by 3 here. So 1800 divided by 3.6 is 500. So your first equation becomes r minus w equals 500, and your second equation when you divide by 3 becomes r plus w equals 600. When you solve those, it's just easy from here. So 550, that's your speed going. And then plug it back in. Looks like the W is 50. Excellent. And there you have it.